Hey guys, so in this tutorial I will be taking a closer look at conditions. Now conditions allow you to check if a value basically has certain properties, or if a value equals a certain value, is in a certain range, or, well, you know, stuff like that. So the first thing I want to show you is the most basic of all conditions, which is the if-then construct. So I'm going to create a variable here. Let's call it int, and it will be an integer value. And I will assign, for example, 5 to that. And now I can just add an if statement, which asks, and this easily translates into English, if our integer variable equals 5, then you have to write it out using a write line into the debug box. And when I run this, it prints out 5. Now I'm going to replace this with the value equals 5. And now I'm going to add an else statement, else, and a write line, the value does not equal 5. So basically what this does is, previously I was just checking if our int value equals 5, and then I said, well, if that's true, then you have to execute this write line. However, now I'm saying, okay, so maybe it isn't true. So if it's not, you have to do something else. And that would be writing out this here. Now, you might notice that I don't have a semicolon on the end here. I'm just going to run this quickly. So prints out value equals 5. If I change this to 6, it says value does not equal 5. Of course it does, but, well, basically I should have changed this one here. Okay, so you get the point. But I don't have a semicolon on the back here, and if I add one there, it will throw an identifier expected error. And this is basically because this is an entire statement. You can just throw this on a single line if you'd want to. No idea why you'd want to do that, but it still works. And it basically means that, you know, this, if you would put a semicolon here, you would just end the statement there. And this is one big statement, so the else just follows on that. However, there is a fairly important exception to the rule, which is if I add begin here. And okay, so I forgot to mention this, you can only do this for a single line. So if I add another line here, it will once again throw an exception. And if I add a semicolon here and here, it will ask again for an identifier. So this only works for a single line. If you want to, you know, do more things, so for example, if the int is 5, and you want to do more than just write out this, you have to start a begin end clause. So now you have this, and this should still work. Yeah, it does, but you should, in theory, put a semicolon there now, because now you've basically created a code block, and you're basically saying, so if the integer value is 5, then you have to execute this code block. And you're basically saying execute this block, and it, you know, the block is considered to be one single entity, and then it will open up that block and it will see like, okay, yeah, there's stuff in there. In this case, just the write line, but for example, you could add another one in there, and well, okay, so I need a, yeah, okay. like that, and this will print out both of those lines. So you can basically execute a whole lot of things in such a code block. And of course the same is true for the else statement. So you add the begin, and you know, that will basically create another code block here. So again, you can add anything you want in there, and I forgot round here. Okay, so if I change this to 6, it will print out this block here. And of course you could replace this block with another if statement. So if I change this to 6, for example, else if int equals 6, then the value equals 6. Okay, like that. So I'm just going to throw out those code blocks because that's kind of cluttering up the place. And you know, you can just go on and add another else to that, and you know, you can just keep going there. So just for demonstration, I'll add another write line here. So write line, the value does not equal 5 or 6. So now it says the value equals 6. If I make this 7, you know, it prints out that. Of course, you can also make the conditions somewhat more complex. For example, I could run this in rounds here and say, well, here I just want to check if the value equals 6 or the value equals 7, for example. So then I'll change this to 6 or 7, and I'll add 7 to this one as well. So when I run this now, it says value equals 6 or 7 because my value is 7 here. If I set this to 8, it prints out this here. And you can, you know, go on here and add 8 to this, and you know, it will work. But at this point it's easier to basically say, okay, so our int value has to be larger than or equal to 6, and it has to be smaller than, well, I'll just ditch this part here, has to be smaller than or equal to 8. And when, you know, 6, 7 or 8, and add 8 to this one. So at this point it's saying, okay, the value equals 6, 7 or 8, because I'm checking, okay, so the int value has to be larger than or equal to 6, and it has to be smaller than or equal to 8. And if I try 9 here, it will just say, okay, it doesn't equal 5, 6, 7 or 8. And of course, as you can see, 5 still works as it should. Now you could imagine that, okay, this is a fairly easy statement, but like if you want to check if int equals, let's say 1, 10, 11, 15, 93, you know, you get a lot of statements there. So it starts to get rather crowded in here then, because they're not really ranges, so you have to keep adding or statements. Well, there's a very easy solution for that, and that's a case construct. This is something entirely different. Basically, you can say, okay, so I want to check a lot of different cases for my int field, and you know, if I do this with if statements, it's going to get to be, you know, one huge big clutter. So I'll just say like, okay, in case int, well, in the case of the value of int, if this value is 5, then just write out the value is 5. If, let's say, the value is 10 or 15 or 60, say OK. The value is 10, 15 or 60. Then you're like, okay, so this is fairly obvious. So you're just checking individual numbers here. For example, I could also create a code block in here. So as before, this only allows a single line. You need a code block for multiple lines. So here the value is 12. But let's say I want to check all of the values from 20 through 29. This could get very, very cluttered. Well, there's an easier solution to that. 20 through 29. So as you can see, you can define ranges in a case, and here I'm saying, okay, so in case of a value from 20 to 29, write out the value is 20 through 29. And to demonstrate this, let's make it 28. And print out the correct text here. And just to test some of the other ones, 60 works just fine, 5 works just fine. You know, you can play with that a little. Now, aside from integer values, you can basically do the same analog with, for example, string characters or extended values or anything like that. I'm not entirely sure, but I believe that SCAR even support strings. So I'm just, well, in cases, it's fairly obvious that it would in if statements, but for example, let's make that hello and define this as a string. Okay, so this should probably work as well. Just picking some random strings here. Oh yeah, so I forgot to change that to string, and that works as well. So you can create case statements using strings as well. And of course you can also check if string equals hello, then do something, and if not, do something else. It's the completely analog to using it with integers. If, for example, you just want to check the first one there, the first character, which is H in this case. Okay, so I forgot another round here. That works just the same. So print out the correct thing as well. So that's basically how you can use conditions, and I will see you in the next tutorial.